We're solving problem 2 from the 2020 F equals MA exam A. A rigid ball of radius r is rolling without slipping along the rib of a right angle chute as shown on this figure. Cross section of the ball taken perpendicular to the ball's direction of travel is shown in this figure. Which of the marked points of the ball have the highest speed? So from this we realize that, these are all the lines, and omega is like how much it's rolling because it's taken perpendicular. We see that points A and B both have instantaneous velocity omega r times the radius times the sine of theta. We can then equate them to say that the velocity of A is the velocity at B equals 0 at this point, equals, well, this would be omega times the radius of the entire sphere times sine of theta, where theta is the angle the point A or B makes to the direction of motion, or like where it's spinning. And then you have to subtract VCM. This gives us the frame. We then get omega equals V sub Cm over R sine theta. We observe that theta is equal to pi over 4, and this is like, so we see this because you can draw it out as such, and then you plug this value into this top equation. So omega is now, this would be 1 over square root 2 equals sine theta. So the square root 2 just gets moved to the denominator. So then this becomes root 2 VCM divided by R. Now for this, we can derive the speeds, but we know from this point on, from this we can tell that the maximum point is going to be the highest point in this figure, and that's going to be point Q. So point Q is our answer because it is the fastest.